Keto diet and longevity. So most people realize that keto is great for burning fat and losing weight. But then they hear on the other side a lot of opponents claiming that the body needs carbohydrate, and if you cut it out too extremely you won't live as long, and it's unhealthy and side effects and so forth. So let's take a really close look at the mechanisms and what's really going on here. So there's a lot of studies out, but one review study I found which was interesting was ketone bodies mimic the lifespan extending properties of caloric restriction. So back in 1935 they found out that rats lived longer if you fed them less. So they reduced their diet, they reduced their caloric intake, basically starved them by feeding them 30 to 50% less than a normal rat would eat. And they found when they did that continuously, then the average lifespan of the rat went from 500 days to 820 days. So about a 60% increase in longevity. And ever since then, there has been this association between calorie restriction and longevity. And they've been able to duplicate this in a number of different species. So it's not just like rats. They've done it with tiny things like yeast or nematodes or fruit flies, but they also done it with mice and primates. So what is it about calorie restriction that makes you live longer? That's what they try to figure out. And they had different theories. Maybe it's that the cells turn over slower, that there's less wear and tear. Maybe it's that the body fat is reduced when you starve the rats. Maybe the fat is so bad that it's to sit on your body that it does bad things and makes you live shorter. Maybe it's the inflammation, because we all know inflammation is bad, and starving reduces overall inflammation. Maybe body temperature, because once you restrict something, once you starve it, the body thinks I don't have as much to burn, so I better conserve it and turn down the furnace so I can last a little longer. Or insulin. They've noticed that a lot of these things seem to do with insulin. So let's look at insulin just a little bit closer and realize that insulin is what they call a mitogenic hormone. What that means is it increases mitosis, and mitosis is cell division or cell replication. So anytime a cell makes a copy of itself, then it divides one time. And they found that you only have so many copies available. It's called a Hayflick limit, and it's tied into longevity and telomeres and so forth, which is a genetic marker of how long you can live based on these cell divisions. And we found that insulin increases the turnover rate. It increases the rate at which cells make copies. So that can be good in terms of growth or repair, but it can be really bad because it also increases cancer, because it makes the cancer cells turn over and replicate faster too. And it's been associated with atherosclerosis, because it makes first of all, it increases inflammation, and a lot of the plaquing is in response to that, but it's also been shown to increase the formation of the atheromas, of the atherosclerosis, which leads to heart disease. And of course, it's been linked to aging, because insulin, if it makes the cells turn over faster, then it increases the rate of aging. So when we look back, because they could never quite figure out which one of these is it, but once we look at this, we realize that insulin has to do with virtually every single one of them, because insulin increases the turnover. Insulin is a fat-storing hormone. Insulin is inflammatory, increases inflammation. Body temperature, I don't know if that would be directly linked specifically to insulin. And of course, insulin is linked to insulin. So most of the reasons for the mechanism is tied to insulin. So what happens when we starve the rats? Well, there's two things that always go together. First is that we reduce insulin, because insulin is there to process carbohydrates, and when you eat less, you're going to eat less carbohydrates, there's less need for insulin. You're also going to increase ketones. So these always go together. Insulin and less insulin and more ketones. They always go together. And it is always healthy. It's always favorable except in one case, and that is in type 1 diabetes, when the insulin goes to 0 and then the ketones go sky high, which is a pathologic disease condition. As long as you have the ability to make some insulin, then it is healthy to increase the ketones. And there's different ways to increase the ketones. So we know it happens in starvation or in fasting, which is prolonged periods of not eating, whether it's voluntary or involuntary. Fasting is generally considered voluntary and starvation is considered involuntary. Exercise will increase ketones and low-carb diets will increase ketones. So the question then becomes, which one is it that produces the beneficial results? Is it less insulin or is it more ketones? And we don't have a clear answer on this, but we don't really have to worry about it because one always follows the other. So if we get one, we always get the other. They both seem to have tremendous benefits to themselves. If we reduce insulin, we reduce 95% of all degenerative disease. When we increase ketones, we tend to get certain observable benefits as well. We can treat various different conditions with it. We know obesity and diabetes improve with ketosis, but they've also found a lot of other neurological conditions that have pretty much been resistant, or they didn't get any results at all until they tried ketones, and things like Alzheimer's and Parkinson's and ALS. Really severe neurological diseases tend to get better with more ketones. One more thing that ketones do is they're metabolized differently inside the cell. So inside your cell you have mitochondria which produce most of the energy for you. The vast majority of all energy used is in the mitochondria, and they have different pathways. And it turns out the ketones go through a more efficient pathway. They can bypass a step or two, and therefore they can produce more ATP, or more of your energy currency per unit of oxygen. So it's more efficient and it produces less damage, less oxidative damage by burning ketones than burning other sources of fuel. And one thing we have to realize, which this is my opinion based on a bigger perspective and a way of observing things naturally, is you don't improve all these different conditions. You can't improve such a wide variety of condition by making someone less healthy. So the biggest detractor for the opponents, the biggest argument is that sure, it helps for obesity and diabetes, but we don't know the long-term effects. It's bad for this, or you have to have carbs, or fat is bad. And they're pulling these statements, but they can't really put the picture together. But the one picture I want to keep in mind is if it brings together, if it improves such a wide variety of conditions, then it's not a bad thing. So ever since 1935, when they first figured this out, the calorie restriction has been a huge topic. It's been something that people say, oh yeah, if only I could do that. If only I could restrict my calories for the rest of my life, then I would live a whole lot longer. But the problem is when you starve yourself, then unless you want to be a rat and they put you in a cage and just feed you half of what you want to eat, you're not going to be able to keep it up because hunger doesn't feel good. The vast majority of people are not going to be able to keep it up. So we know that calorie restriction improves insulin and ketones. It reduces insulin, increases ketones, but you get hungry. So wouldn't it be nice if there was a way that you could reduce insulin and increase ketones without going hungry? And I know I've heard about something. I think there's something I heard that could do that, but no, wait, here, it's coming to me. Oh yeah, the ketogenic diet, that's what it is. Because when people do that, they reduce insulin, they increase ketones, but they don't go hungry. And this is not so easy to understand for people who haven't tried it, but once you try, then you notice that your body wants fewer meals. Because fat is very satisfying, then you can go longer between meals. So in the end, you end up eating a little bit less, maybe not less calories, probably a little bit, but maybe not. But the main thing you get is reduced insulin and increased ketones. So you get these anti-aging benefits, you get all these health benefits because it is primarily about the insulin and possibly some about the ketones, but it's certainly not about the calories. The reducing of the calories only results in changed insulin and ketones. It's not the calories per se. So please share this video with anyone that you care about because we want to get as many people as possible healthy. We want to help people understand the true principles, the true mechanisms around health, not just memorize a laundry list of things to do because that's short-lived. But once we understand the mechanisms, the big picture, then we can start creating a long-term healthy lifestyle. So leave your comments and questions below, and thanks for watching.